Okay, so this is section 2.2, which is modeling with power functions. So what we're going to talk about is power functions and variation, monomial functions and their graphs, and graphs of power functions, and modeling with power functions. Okay, so a power function is any function that can be written in this form. So we have f of x equals k times x to the a, where k and a are non-zero constants, and it's a power function. So the constant a is the power, so a is the power, and k is either the constant of variation or constant of proportion. And we say that f of x varies as the eighth power of x, or f of x is proportional to the eighth power of x. Okay, so our first example is analyzing the power functions. So we're going to state the power and constant of the variation for the function and graph it. So if we have f of x equals the fourth root of x, we can rewrite this using exponents, and we can say f of x is equal to x to the 1/4. So remember, raised over rooted, so x has a power of 1, the root is 4, so f of x equals x to the 1/4. So that means that our power is 1/4, and then the constant of variation is the number out front that's being multiplied. So the constant of variation is 1. Okay, another example of this, because you might come across different examples. If we say g of x equals 1 over x squared, knowing how to take, if we have an exponent in the denominator and rewrite that, it's going to be g of x equals x to the -2 power. So again, if you have exponents in the denominator, to bring it up to the numerator, you're making it negative. And so our power would be -2, and our constant would again be 1. Okay, so that's analyzing power functions. So a monomial is any function that can be written as either f of x equals k or f of x equals k times x to the n. And k is a constant, n is a positive integer, so positive integer. And that makes it a monomial function. So something like f of x equals 2 times x to the third. That's a monomial. Something like g of x equals 3 times x to the -4th would not be a monomial because it's not a positive integer. Okay? So example 3 is graphing monomial functions. So we're going to describe how to obtain the graph of the function f of x equals 3x to the third from the graph of g of x equals x to the n with the same power n. So then it says to sketch the graph by hand and support your answer with a grapher. This just means like graphing calculator or Desmos or something like that. Okay. So first of all, if we're talking about the original parent function, g of x equals, so this would be g of x equals x to the third power. So if we're comparing f of x to, which is 3x to the third, that 3 out front is going to be a vertical stretch. So we could say this graph is going to get narrower, or we're stretching vertically. So if we kind of sketch that as our parent function, and then so 3x to the third might look something like that. So that would be our transformation. Okay, and then the last part says for any power function where we have f of x equals k times x to the a, one of the following 3 things happen when x is less than 0. So these situations over here are when x is not less than 0. So this is saying this right here is when k is greater than or equal to 0. So this is in quadrant 1. And this is when k is less than or equal to 0, and this is in quadrant 4. So you could type these into your calculator. You could pick an a value, you could pick a k value. So you could say f of x equals 3 times x to the second power. And you know you'd follow the red line because the a value is greater than 1. You could say f of x equals 3 times x to the 1/2 power. And then you would follow the blue line because your a value is between 0 and 1. And then you could pick a negative a value and see that it's following the green line. If the other option, so this is when 3 things happen when x is less than 0. So your x value now, you have 3 situations. You have that f is undefined. Okay, so if you think of like f of x equals like the square root function. So your square root function is undefined for x is less than 0. You could also have an even function, which is symmetric about your y-axis. And then the third situation is that you have an odd function, which is symmetric about the origin. So that's like rotational, 180-degree rotational symmetry. So these are your situations. Again, these graphs here are when x is greater than 0, and these 3 situations here are talking about when x is less than 0. Let me know if you have any questions.